Okay, everyone. So today we're going to start looking at types of circuits. So we have circuits that are known as series and circuits that are known as parallel circuits. So actually up until now, all the circuits that you've been drawing have been in fact series circuits, which is what we're going to start looking at today. I'll just kind of preview this for you. So let's say I have a 2-cell battery and I have couple of light bulbs and a closed switch. Okay, so a series circuit is where you have one single pathway for the electrons to flow on. So I'll use a highlighter here. So the electrons go out of the negative terminal, they're going to go through this light bulb, and then go through the second light bulb, and then make their way back, right? So basically they went around in one path. So there could be multiple things in that path, multiple switches or a fuse, light bulbs, a motor, whatever it is, a resistor. But the point is there's one pathway. Okay, so that's where you have one path. Okay, so that's a series circuit. So just to preview what a parallel circuit would look like, just by comparison. Okay, so this is now where you have multiple pathways. So basically there reaches a point where, let me use blue for one. Okay, so one will be, and we'll make this smaller. So let's say the electrons are moving along. At this point, there's like a fork in the road. So some electrons can go on the first line path. Let's say this, like going in a straight line, or they can go down this way. So there's now a fork in the road. So the electrons were all together on the blue path. Maybe I'll change the color here. Yes. Okay. So on this blue path, they were together. But then at this fork in the road, the electrons basically split up. So some electrons went down one path, some went down in the other. Now at this point here, they're now going to rejoin each other once again. So a parallel circuit is where you have more than one pathway. Okay, so as soon as you see there is a fork in the road where there is essentially options for the electrons to flow down one way or another, you know you have more than one path. Okay, so today we're going to focus on, like this lesson is going to focus on series circuits. You already know how to draw these because you've been doing that this whole time from when you started learning about the symbols for circuits. But what we're going to focus on today is the different components of a circuit in terms of energy. So voltage, current, and of course resistance. Okay, so a series circuit is where you have only one path for the flow of current. So the electrons are flowing in only one direction, or I should say only one path. The current, so there's three things, right? Three variables that we look at in circuits: current, potential difference, or voltage and resistance. So current is always exactly the same no matter where you measure the current. Okay, so these are not really formulas. They're more like relationships, okay? So whenever you see the S, so that represents the source or battery. Sometimes you'll see it as a T for total. They mean exactly the same thing. So what this is showing you is that the current, let's say we were to measure the current 3 different spots or 3 different locations, they would all be exactly the same. Okay, so let's look at a picture to kind of show that. why not? Let's add a resistor. Okay. So remember that current is measured using an ammeter, correct? So ammeters are essentially placed in portions of the circuit to measure the current, or essentially look at how many electrons are flowing per second, how many coulombs per second are flowing by. So where I decide to measure the current can be in a bunch of different locations. So maybe I want to measure the current coming out of the battery. Maybe I want to measure the current right here. Maybe I'll measure the current here, or here, or here. Like maybe I'm going to measure the current in a bunch of different locations. I'm going to move my ammeter around. So usually when you're looking at circuits, they give them associations, so like letters or numbers. So for example, the current that is coming out of the battery is usually called our IS or IT. Okay, this one, let's say we call this current number 1. We'll call this one current number 2, current number 3, current number 4, right? Like they're just kind of numbered off. So over here where it says like I1, 2, 3, they just mean 3 different locations. Okay, that's all that means. So you can measure it really at 1 location, at 2 locations, or like 10 locations. It doesn't really matter how many you're doing. So in this particular one, I have the current that's at the battery, and then I have like 4 other ones. Okay, so the relationship in a series circuit is that no matter where I measure it, the current is going to always be the same. Now, the reason why that is true is because the number of electrons flowing here are always the same. There's only one pathway. So what that means is the number of electrons flowing at I1 is the same number of electrons flowing at I4 because there's nowhere else for them to flow. They're stuck in this one pathway. So let's say, let's use a different color here. Let's use red. So let's say at I2, I hook up my ammeter and it reads 3.0 amps. As soon as you know one of them, all of them are exactly the same. Because the number of electrons passing through per second is identical, because really that's the only location where they could possibly be. There's not multiple pathways or multiple options. They're all on the same path. So that's the relationship for current, is basically that it's always the same. And remember, we're talking about series circuit only in this lesson. Now, when we're talking about potential difference, the relationship is different. Potential difference in a circuit is additive. So what that means is that the battery, so remember the S represents source or battery, right? It could also be VT for total. So the battery voltage is equal to all of the voltages that are used up in that circuit. So let's draw us a circuit so we can kind of talk about why that is. Okay, so I want you to think of voltage or potential difference as currency, okay? Because remember, potential difference is the amount of energy that the electrons are carrying or that they have. And that's produced at the battery, okay? So the voltage at the battery, so the VS, so we'll call this V1 and V2, okay? So first of all, remember that voltage can only be measured in 2 spots, at the battery or at a load, okay? So current is different. Current, remember that current is measured with an ammeter. That is measured on a line, like on a connecting conductor. So my ammeter would be here, or my ammeter would be right here, right? But if you remember from the potential difference lesson, voltmeters are connected in parallel. So what that means is the voltmeter is hooked up around the light bulb, like around that connecting area. So usually what you're doing is you're measuring the energy coming into the bulb and going out of the bulb. And the difference between those 2 points, remember it's potential difference, that is what the voltmeter measures. Okay, so that's why I kind of like to think of it as currency, because think of it. Let's say the battery generates, I'm going to make up a number here, 10 volts. Okay, so the battery is giving those electrons 10 volts worth of energy. So what that means is as those electrons travel around the circuit, it's going to use those 10 volts up. So you have to basically look at, well, where is it going to spend its energy? So it spends its energy passing through loads, because the loads, as it slows down in the load, the energy is converted. So in the case of a light bulb, it's converted from electrical energy into light energy and heat energy. So let's say at this light bulb, so imagine that I'm in a little electron, I'm traveling down. When I come into this bulb, I have all of my 10 volts worth of energy. But as it passes through, it's going to spend some of that. So let's say it's now when it came out, it has 7 volts of energy. So what happened here is, the amount of energy that has been spent is basically 10 minus 7. So this voltmeter number 1 will be 3 volts. It has spent, those electrons have used up 3 volts worth of that energy. So of course the electrons are going to keep moving along. It's going to enter into this bulb with 7 volts and leave, let's say, with 0 volts. Okay? So what that means is at this location, it spent 7 volts. This was a 7-volt light bulb, a 3-volt light bulb. When it returns, those electrons have now 0 energy. So the battery potential difference is equal to all of the loads that are in that circuit added together. So remember, a load can also include, loads also include resistors. Okay, so light bulbs, resistors, motors, those are all types of loads. Okay, so once you know some information, and you'll see when we do examples, once you know some information, you can kind of figure out what the other things are that are missing. Let's just do one quickly. Just do like a simple little guy. Okay, so let's say, so here's my VS, here's my V1, V2, V3, right? So let's say I said V2 was 2 volts, V3 was 5 volts, and VS was 9 volts. Okay, you should be able to figure out what the missing voltage is here, because if you understand the relationship, you can kind of solve for it, right? So you know that V1 and V2 and V3 should add up to 9 volts, because that's what the battery voltage is. So basically through subtraction, you can figure out, well, what's the remaining amount? So if this is 5 and this is 2, that means that V1 had to be 2 volts for them all to add up to 9. Right? 5 plus 2 is 7, 7 plus 2 is 9. Hopefully that kind of makes sense, right? Okay, and then the last relationship, actually this exact same relationship we had with voltage happens with resistance. Remember, RT, RS are exactly the same thing. So the resistance in the source or at the battery is equal to the resistance of all the loads that are in that circuit. So each load has its own resistance, and just like it uses up its own amount of energy, And all of those resistance added together will equal the total amount. Okay, so let's do an example of that. But it's literally the same relationship. Okay, so let's say we had, so this would be R1, R2, and then RT is for the battery. So let's say R1 was 0.5 ohms and R2 was 2 ohms, right? Can we figure out what the total resistance is here? Of course we can, right? As soon as you understand the relationship, you know that these two added together has to equal RT. So RT would be 0.5 plus the 2, which would be 2.5. Okay? So very similar. Once you kind of understand, right, the voltage relationship, resistance is literally identical. Okay, so let's take a look at another example here. So this is a very typical type of question that you would get. So this is where you have basically some information is given and you have a bunch of question marks and you have to solve for the things that are missing. Actually, let's continue this in the next part.